Well, I think we've come a long way on this. We got good quality. We got decent coloring. We got decent dynamic fog. I think we've got a pretty good quality graphic by having modified our quality related parameters, DE stop and that sort of thing. I'm just not really happy with the contrast. So what I'm going to do is I'm going to go to the lighting panel, get down to the gamma, and I'm going to modify that. You see how you see now that's improving my contrast. Now obviously I'm going too far. Now here I'm going too far the other way. But what I want to do is I want to get a contrast that looks pretty good. Okay, so here it's a little washed out. Okay, here it's a little dark. I don't want black shadows. I don't want that. I want realistic looking shadows. Good. Okay, good. All right, now I need to apply that to all the keyframes. All right, and this is checked on. All right, so you know the routine. All right, and I'm going to save this. Okay, I'm going to save this 130, and I'm going to say final changes. Okay, good. Okay, okay. Now this is taking 22 seconds to render a frame. So if I have, matter of fact, tell you what, let's just save this here. All right, we're going to save our animation. Okay, after changes, good. All right, so I've got everything saved. I got my animation saved. I got my project saved. Now, each of these frames is taking 22 seconds to render, and I have 4,225 frames. So if I go 4,225 frames, all right, let's clear our canvas here. Get my stylus here. Okay. Got 4,225 subframes, and it's taking 22 seconds, all right, per frame. All right, times 22. So this is going to take 9,295 seconds to render all of those frames. If I divide that by 60, it's going to take 1,049 minutes to render all of those subframes. If I divide that by 60, come on, it's going to take 25 hours to render all of these subframes. Now, that is with, let's go over to the infos. Let's go over to internal. We are, believe it or not, coming up on what we'll refer to as rendering. You made it. Okay, you made it. Finally. Now, the internal tab here is indicating how many cores this particular computer has. All right, it's an i9. It's an Intel i9. It's got 32 gig of RAM. It's got a pretty robust GPU in it. Now, Mandelbulb3D does not use a GPU for rendering. Doesn't use it. It uses cores only. All right? The more cores you have, the faster this thing will render. Oh, all right, let's try something here. Let's get my task manager going here. All right, this is my task manager, and I want to look at CPU. And here are all of my cores, all right, of this particular CPU. Here's an i9, a 10900K CPU. A K means it's overclocked, but I have not overclocked this particular CPU, this computer, and it is running at 3.7 gigahertz. There's my 20 cores. Now, what I'm going to do is I'm going to render this, and I want you to watch all the cores. So let's calculate this, and I'm not going to cut the film so that you can watch the whole rendering process. Here we go. Okay. So you see here that all of the cores were utilized. All were utilized. So that's good. That's very good. So the rule of thumb is that the more cores you have, the better. This took 22 seconds. If I had a 4-core, maybe an i7 4-core, and an i7 is a pretty respectable computer, CPU, it probably would have taken maybe 2.5 minutes to run. So the rule of thumb is this, is that the more cores you have in your CPU, the better. Now, life is not ended as we know it, because the Mandelbulb 3D software has the ability to do what's called network rendering, where you can have multiple computers that will all be working on the same animation and writing into, say, a network folder or a disk location that all of your computers can get to. All right. So there's nothing wrong with having, say, 4-core i7s working. That would give you, what, 16 cores effectively? All right. You don't have to have a big honking computer to work with the Mandelbulb. You can do network rendering. I'm going to show you more about that as we go along. But now, refocusing here. So we've established here that the Mandelbulb will use all of the cores unless you tell it not to. All right, you can come in here and you could say, look, just use 10. Sorry, I can't type it. You got to just use 10 cores. You can if you want. I mean, it's crazy. You might as well use all of the beef that you have. If you knock this up any higher than you actually have cores, well, it's going to ignore that. So typically, all right, typically you want this number here to represent all of the cores so that the Mandelbulb 3D, when it renders, will use all available cores. Now, what this means here is thread priority. These are all threads. And a thread is an individual program sequence that can run independently of the other threads. So you could have a thread here, a thread is running here, a separate thread here, a separate thread here, 20 threads. When it comes to talking about hardware, we'll call these cores. But in terms of software, these are actually threads. They're independent software program sequences that are running separate from one another. So now what you can say is make it so that the the Mandelbulb software will only use threads that are idle, or that for the Mandelbulb 3D software to be treated as the lowest priority. So, you know, you got your Windows operating system, and it says, look, you know, I need that CPU core or thread to do some word processing, all right? And then Mandelbulb comes along and says, well, you know, I want your attention too, all right? And so if you set that for lowest, you're basically telling the operating system to treat Mandelbulb 3D as a lower or lowest priority when it comes to using the thread or using the core, all right, or lower or normal. In other words, just let the operating system figure out how to utilize the threads, all right? And keep this priority simply means that you know, when you close the application and start it up again, it'll keep this priority setting. And disable thread boost. Most some CPUs, if they're overclocked, will have the ability to kind of boost or accelerate the threading. All right, and all this is saying here is, you know, turn that off. And I don't really know the use case for that, but I would think that you want to have you want to allow the operating system to decide the threading. You don't want to try to have the Mandelbulb 3D software force the thread priority onto the operating system. You want to let the operating system figure out what's going on and handle the threading. I always leave these two off. No need for anything else. Lastly, this is the Mandelbulb version. All right, that's the current version. That's the only place you're going to find the version is right there. All right, so we're over time on this session. Why don't we pick this up in the next session, and we'll continue talking about rendering. I'll see you there.